The History of Algebra by Maria McEvoy, Kelsey Sellers, and Jennifer Tran. Algebra, more like algebra, is a noun. It is the part of mathematics in which letters and other symbols are used to represent numbers and quantities in formulas and equations. The history of algebra began in ancient Egypt and Babylon, where people learned to use linear and quadratic equations, such as the indeterminate equation. The ancient Babylonians solved arbitrary quadratic equations by essentially using the same procedures used today. The Alexandrian mathematicians Hero of Alexandria and Diophantus continued the traditions of Egypt and Babylon, but Diophantus' book Arithmetica is on a much higher level and gives many surprising solutions to difficult indeterminate equations. Ancient civilizations wrote out algebraic expressions using only occasional abbreviations, but by medieval times, Islamic mathematicians were able to talk about arbitrarily high powers of an unknown x and work out basic algebra polynomials. This includes multiplying, dividing, and finding the square root. Persian mathematician, astronomer, and poet Omar Khayyam showed how to express roots of cubic equations by line segments obtaining by intersecting conic sections, but could not find the formula for roots. In the early 13th century, the great Italian mathematician Leonardo Fibonacci achieved a close approximation to the solution of the cubic equation. Early in the 16th century, the Italian mathematicians Scipione del Ferro, Niccolò Tartaglia, and Girolamo Cardano solved the general cubic equation in terms of the constants appearing in the equation. Later on, Cardano's pupil, Ludovico Ferrari, soon found an exact solution to the equations of the fourth degree, also known as the quartic equation. Early in the 19th century, however, the Norwegian mathematician Niels Abel and the French mathematician Évariste Gayos proved that there is no such formula that exists. The book La Géométrie, written by French philosopher and mathematician René Descartes, looks much like modern algebra texts. Descartes' most significant contribution to mathematics is his discovery of analytic geometry. His geometry text also contains his so-called rules of signs for counting numbers called the true and false roots of equations. Work continued through the 18th century on the theory of equations, but not until 1799 was a proof published by German mathematician Carl Friedrich Gauss. Carl Friedrich Gauss then enters the modern phase of algebra. Groups began as systems of permutations and combinations of roots and polynomials, but they became one of the chief underlying concepts of the 19th century mathematics. Important contributions to their studies were made by French mathematicians Gayos and Augustin Cauchy, the British mathematician Arthur Cayley, and the Norwegian mathematicians Niels Abel and Sophus Lie. Quaternions were discovered by British mathematician and astronomer William Rowan Hamilton, who extended the arithmetic of complex numbers to quaternions. Immediately after Hamilton's discovery, the German mathematician Hermann Grassmann began investigating vectors. Despite its abstract character, American physicist J.W. Gibbs recognized in vector algebra just as Hamilton had recognized the usefulness of quaternions. The widespread influence of this abstract approach led George Poole to write The Laws of Thought, an algebraic treatment of basic logic. Since that time, modern algebra has continued to develop.
"200 years later.
Important new results have been discovered, and the subject has found application in all branches of mathematics and in many of the sciences as well.